information systems. Make sure you look over the objectives. We talked about levels of management. We talked about levels of information. Triangles get smaller because it gets smaller as we move up, because here we have typically less people involved at the different levels. Flattening of an organization look more like this, here and here, very few people in the middle. Technology has caused a flattening of organization because we don't need as many middle managers. We need a small amount of information. Got that big database here. Database management system. We need a smaller amount of information that's summarized and really specific to the question being asked. Down here we lots more information and less in the middle. And this could look more flat too, because technology drives so much of how businesses work. We talked about the different types of decisions. Structured decisions are clear-cut decisions, and if they're clear-cut, they can be made by technology, right? You can, without even a checker, you can go to a store and take the product, slide it by the barcode, and it does the work for us, because once it gets that number, it can easily go to the database, right? Go to the database, get the information it needs, and brings it back up. So many things that technology can do, structured decisions. Somewhere in the middle, we use information to help base our decisions, and non-structured are much more difficult to make. We'll talk later on a little bit about artificial intelligence might help us in that area. We talked about whether we detail information, summarize, and now most data is current, and then different systems, decisions. Development. Okay, so in general, we'll talk a little bit about top-down design. Top-down design, we use this method as we move. Once we understand the problem, we can analyze it, design a solution, develop the solution, okay? And we have all kinds of tools to help us do this work. Remember, in development, you actually start buying, that's where you buy the hardware and start installing the software. Software. In the design, and somewhere in the analysis too, you decide if the software buy, make, or customize, where you're going to be at on that. And we talked about all the advantages and disadvantages. You figure out, and all the testing is done here, you figure out how you're going to implement it, then you're going to evaluate it, see if it's actually producing the results it should, then we update. Whether that could be some updates to hardware or updates to software, and we create these feedback loops. Make sure we understand the problem, make sure the analysis is correct, we keep feedback on the design to ensure that's correct. As we're developing, we get feedback, and then same thing for implementation. Make sure it's working. See you later. Okay, so update, maintenance, sometimes that'll take us all the way back up here. What is the new problem? Analyze it, design a solution, develop it, implement it, and then make sure the update is working. So we have here a cycle in which we keep going through and through the cycle, and eventually you can only update so much and you have to throw it out and start over new. So that's a top-down design, okay, in which you do all that work from the top down. A bottom-up design is used a lot, sometimes referred to as rapid prototyping. On a bottom-up design, you have the problem. It could be very similar, problem, situation, whatever, and that needs to be defined. You can't solve anything unless you're sure you know what you're trying to solve. Okay? Then you do a quick analysis, and then you design and build a prototype. Okay, build and design a prototype. So, a great example, you can have a couple simple examples. A lot of people do spreadsheets like this. They will start and just start right in and make the spreadsheet and then adjust it and change it as they go along. Another example would be presentations software. You don't see too many people draw out an entire storyboard and then put it in some presentation software. They just start building it and going as they go. Okay. An example was I built a treehouse many years ago, and I used bottom up. The first thing I did is I got all the wood, because I went to the lumber yard and got their cheap call lumber, they used to call it, half price. And then based on what wood I had, I put a board on the tree. Here, I can make that look more green. Put a board on the tree, made sure I could walk underneath it when I mowed. And from there, then, I built the treehouse. You know, just by taking what I had and fitting it together and however it turned out. That worked okay for the treehouse, but if I would have made a major error when I first started building it without any design, if there was a flaw in it, I would have had to maybe start over, or at least tear down a good share of it and start over. Prototyping is really popular in a lot of different ways in developing software and designing systems, because top-down design might take too long. Okay, it just might take too long, and technology changes while you're doing that. But when you do a prototype, you better be able to redo it if you have a major error, or you better be satisfied with the results, because you may not take into all situations, and some of it may have to just be used as is if you can't adjust it. So, if we were to think about the difference between them, top down, bottom up, a lot of cases this will work. What cases does this have to be used? Where you have to make sure you analyze all the possibilities and situations and so forth. Well, let me give you a few quick examples. We can't afford software to fail at air traffic controllers, subways, our power grid, etc., etc., etc. Some financial institutions, and some, you know, there's a whole array of things in the world that have to be done top down, because we can't afford to have them fail. All right. We'll do a slight review of that later.